Question 2 asks, when 412.5 grams of calcium carbonate react with 521.9 grams of aluminum fluoride, how many grams of each product can be produced? You start off by writing out the balanced equation. Then using the balanced equation, you look at the mole-to-mole ratio between calcium carbonate and aluminum fluoride. Then using the 412.5 grams of calcium carbonate given to you in the beginning, you divide that by the molar mass of 100.1. That gives you 4.121 moles of calcium carbonate. We do the same thing with the 521.9 grams of aluminum fluoride, dividing that by its molecular mass of 83.98 grams per mole, giving you 6.215 moles of aluminum fluoride. Then, using the moles that you had found to find the limiting reactant, you divide by the molar ratios. So 4.121 moles of calcium carbonate gets multiplied by 2/3, while the 6.215 moles of aluminum fluoride gets multiplied by 3.5. You're given 2.741 moles of aluminum fluoride and 37.29 moles of calcium carbonate as your answers. The limiting reactant after doing the math is calcium carbonate, because 4.121 moles of calcium carbonate present is less than 37.29 moles of calcium carbonate needed. Then, using your limiting reactant and the balanced equation, you see what the ratio between moles of calcium carbonate to calcium fluoride is. And since it's a 1:1 ratio, the moles of calcium carbonate equals the moles of calcium fluoride. So you have 4.121 moles of calcium fluoride. To find the grams of calcium fluoride, you multiply the 4.121 moles by its molecular mass of 78.07 grams per mole, giving you 321.7 grams. You do the same thing with the aluminum carbonate, and there's a 3:1 ratio of moles between calcium carbonate to moles of aluminum carbonate. So you multiply 4.121 moles of calcium carbonate by 1/3, giving you 1.374 moles of aluminum carbonate. To find the grams of aluminum carbonate, you multiply the 1.374 moles by 233.99 grams per mole, which is the molecular mass, giving you 321.5 grams. Question 3 gives you the following information. When 227 grams of Na2SO4 reacts with 137 grams of Ca3P2, according to the following equation, how many grams of the excess reactant are left over? Using the balanced equation, use the molar ratio between Na2SO4 to moles of Ca3P2. Since there's a 2:3 ratio after looking at the balanced equation. Now, using the information given to you, you multiply the 277 grams of Na2SO4 and divide that by 142 grams per mole, which is its molecular mass, giving you 1.95 moles of Na2SO4. Then, using the 137 grams given to you in the beginning, you divide that by 182, which is its molecular mass, giving you 1.753 moles of Ca3P2. Using the moles that you had just found, you're going to multiply the 1.95 moles of Na2SO4 by 2/3, giving you 1.30 moles of Ca3P2. You're going to do the same thing with a 0.753 moles of Ca3P2, except this time you're multiplying it by 3/2. This gives you 1.13 moles of Na2SO4. After doing these calculations, you find out that your limiting reactant is Ca3P2, because the 0.753 moles of Ca3P2 present is less than the 1.30 moles of Ca3P2 needed for the reaction to occur. Then, using the 0.753 moles of Ca3P2 found earlier, you multiply it by 3, giving you the 2.26 moles of Na2SO4. Now, to find out how many moles are in excess, you do the entire moles minus the excess moles, giving you 0.31 excess moles of Na2SO4. Multiply the 0.31 moles of Na2SO4 by its molecular mass of 142.04 grams per mole, giving you 44.03 grams. Now, how many grams of Na3P are produced? Since there's a 1:2 ratio of moles of CaSO4 to moles of Na3P, you multiply the 0.753 moles of CaSO4 by 2, giving you 1.51 moles of Na3P. The 1.5 moles of Na3P gets multiplied by its molecular mass of 99.9, giving you 151 grams of Na3P.